Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we're going to talk about a couple of questions that a student had on his Big Ideas Geometry Review, Chapter 8. This corresponds with similar triangles and similarity. Now, this does also apply with some Course 3 material, so 8th grade math. The 8th grade math actually also has similar triangles, similar shapes. And so one of the things that I was working on with another student today on similar triangles, as well as these particular problems, was that we noticed that we can actually find the scale factor of all of these sides in order to determine if these two are actually indeed similar. So one thing that I showed him was if we can take the sides of this particular triangle first and label them or put them in order from least to greatest. So for example, 12, 16, and 20. And then we do the same thing with the other triangle, the bigger triangle or the second triangle or whatever the case may be. And we do the same thing. We put those in order from least to greatest, 15, 20, and 26. We'll notice that the 15 and the 12 actually correspond, which works really nicely in this fraction here. We'll notice that the 16 and 20 also correspond, and the 20 and the 26 also correspond. So our goal is to really see, are these scale factors, if you will, these fractions, are they congruent? So if I can go ahead and I can simplify each of these ratios and they do indeed equal each other, then boom, beautiful. Then these two triangles are actually similar. So let's go ahead and let's simplify this. I know that 12 and 15 I can divide by 3. So when I divide 12 by 3 and 15 by 3, I get 4/5. So far, this is the fraction that I'm looking for from these two. Now, I can look at this guy and say, I know that 4 goes into both of them, but if you don't know that right off the bat, you can definitely say something like, hey, I can divide by 2 and then divide by 2 again, because your answer will be equal, okay? So it doesn't matter how you get there, you just need to get there, okay? It may take you 1 step, 2 steps, 10 steps, so long as you're there. So now I'm going to divide this by 4 and this by 4, and I'm going to get 4/5. Okay, so far these two equal. Now, really, we want to know, does this last one equal to these two? And if it does, then yes, these two triangles are similar. If it does not, then wah, 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 they are not similar. Okay, so 20 and 26, I cannot divide them by 4 and I cannot divide them by 3, but I can divide them by 2. So 2 goes into 20 10 times, and then 2 goes into 26 13 times. Oh, no. These are not similar. These are not similar triangles. It is super sad. Similar. I think I spelled that correct. Not quite sure. But these are not similar triangles. Okay, so if I have these as not similar, then I'm going to move on to my next problem. The only time that I would actually make a similarity statement is if they are indeed similar. Since they're not, I can move on to the next problem. Okay, so in here, I'm actually told that two angles, or these top angles, are 48 degrees. So I also know that every single triangle actually adds up to 180 degrees. So if I add 48 plus 66 plus my angle G, I should get 180 degrees. And I shouldn't forget my notation. This should be measure of angle G. And then if I do the same exact thing here, if I do 48 degrees plus 77 degrees plus the measure of angle Y, that should also be 180 degrees. Now, this is going to be 114. Yeah, 114 degrees plus the measure of angle G is 180. I'm going to subtract 114. Whoops. That'll cancel. So the measure of angle G, if that equals 77, then I'll know that this triangle and this triangle are the same. However, 10 minus 4 is 6. And I know right off the bat, my ones digit for this angle is going to be 6. So I know these are not similar. But if we were to go on ahead and do this, it would actually be 66. And then 18 minus 11 is 7, but then minus the 1, so 66 degrees. So since this is 66 degrees, this will not be 66 and 77. So it'll be something different. So again, these are actually not similar. Now, let's say that they were similar. Let's say that I had two triangles that actually were indeed similar. And so I'm going to just draw two that we're going to make pretend they are similar without doing any math. So let's say I have ABC and then I have XYZ. We're going to make pretend that they are similar, that they look similar and all that jazz, and they're actually complete triangles. Thank you for bearing with me. If I know that angle A and angle X are the same, and if I know that C and Y are the same, and if I know that B and Z are the same, I'm going to need to create a similarity statement. So I know that triangle A is going to be similar to triangle X. Now, what I'm going to do is I'm going to kind of break it apart. C and Y are the same, right? And then B and Z are the same. So whether you have different colored pens or pencils or markers or whatever it is, your goal is to actually just create the similar triangles. Your goal is to see which pieces are similar so that you can actually combine them into a full triangle name and go in and say, hey, ACB is the same thing as XYZ, right? Because I have red, green, blue is the same thing as red, green, blue. It would look a little weird if I would have red, green, blue, and then blue, green, red, right? That's kind of not the same because the angle measures are not the same. They're all different, right? So that's the goal. You want to make sure that you're putting the similar things together in the same order, in the same pattern, okay? I will see you in another video. And for now, goodbye.